All right, so in the last lesson, we learned about the three major trig functions and we started identifying which sides are used for each one and started setting them up. Today, we're actually going to be solving those trig equations once they're written to find missing side lengths. And then in the next video, we will find missing angle measurements. But today, we're going to start out with finding missing side lengths. So, quick reminder, three trig functions that we're going to be using are sine, cosine, and tangent. And we had that nice little acronym, SOHCAHTOA, to help us remember which sides go with which. So sine is opposite and hypotenuse, cosine is adjacent and hypotenuse, and tangent is opposite and adjacent. So we also had another vocabulary word yesterday, and that was the reference angle. And your reference angle is where you're looking from. So we talked about Bob. We could put Bob wherever we want at one of these two acute angles. Never at the right angle, but at one of the two acute angles. So if Bob were standing right here, then angle A, which is 30 degrees, would be our reference angle. And if Bob were standing up here at B, then the 60-degree angle would be our reference angle. Now, the reason that's important is because wherever Bob stands, that's going to determine where the opposite side is and where the adjacent side is. Now, your hypotenuse will always remain the same, so you don't ever have to worry about that one. So, if Bob is standing here at the 30-degree angle, then BC would be my opposite side because it's all the way across the triangle from Bob, and then AC would be your adjacent side. So we did talk about this a little bit yesterday, so maybe you remember. But we talked about because all 30, 60, 90 triangles are similar, as long as Bob is standing at the same reference angle, the ratios of the specific sides, the sine ratio or the cosine ratio or the tangent ratio, will always be the same because you are having the same scale factor in between your shapes. So for instance, if this side were, 4, then using my 30, 60, 90 triangle, this side would be 8, and this side would be 4 root 3. And then if I made this side 6, then this would be 12, and this would be 6 root 3. So hopefully you remember those shortcuts there. So if I were going to do the sine of 30 for this triangle, sine is opposite over hypotenuse, so it would be 4 over 8, so that's 1/2. And if I do the sine of the exact same angle over here, even though the length is different, 6 over 12 opposite over hypotenuse, you get the exact same ratio. You still get that 1/2. So no matter how long your sides are, as long as your triangles all have the same angle measurements, the ratios will be the same. Same thing if I did the cosine of 30, that'd be adjacent over hypotenuse, and that reduces down to, so this is 1/2, so 1 root 3 over 2. And if I do the exact same reference angle here, even though the side lengths are different, adjacent over hypotenuse, 6 root 3 over 12, this is still 1/2, so 1 root 3 over 2. So what's really nice is your calculator, somebody actually went through and found all of the ratios for us, and then in your calculator, they've been all saved. So 1/2 is 0.5. So in your calculator, when you type in the sine of 30, it'll spit out the decimal 0.5. So when I type in sine of 30, you can see that it spits out 0.5, which is exactly what we got. The sine of 30 was 1/2 is 0.5. The cosine of 30, now it spits out this crazy decimal. I'm going to write that down. So 0.86602544038. If I type this fraction in, I'm going to get the exact same decimal. So I'm going to do 1 square root of 3 divided by 2. And you can see that I get the exact same decimal. So somebody's actually gone through and saved all of these ratios for us in our calculator, which is really nice. We don't have to memorize them. The calculator already has them. So the next part that's going to be really important here is knowing how to use your calculator. Every calculator is a little bit different, so it's going to really depend, the order you type things in is going to depend on the kind of calculator you have. So I have a graphing calculator. If you have a graphing calculator, or if you have a calculator that you can actually see everything you type before you hit enter, so like 8 plus 5 minus 6 times 9, like I see all of it before I hit enter, then you're going to type things in the order that they're written on your paper, or the order that you write them down. So sine 45, cosine 30. So I would do sine 45, hit enter. Or I would do cosine of 30 and hit enter. Now I don't have the other kind of calculator with me, but sometimes it's like the gray TI 30X solar ones. But if you type stuff in and it kind of, you can't see everything you're typing in and it spits out an answer right away, you have what I refer to as a backward calculator. And I only call it backward because you have to type things in backward. So like for sine of 45, you would have to type in 45, hit sine, and then hit equals. So it's really important for you right now to play with your calculator and see which kind of calculator you have, okay? So when you play with your calculator, this is how you're gonna know if you got it right. When you type in the sine of 45, you should get 0.7071 ... When you type in the cosine of 30, you should get 0.8660. When you type in the cosine of 77, you should get 0.22495. And then the tangent of 7, 0.12278. So play with your calculator and make sure you can get them to spit out these things. There's a couple things you can do if it's not working. One, try the other order. So if you tried typing in sine 45 in that order and it didn't give you this number, if it spits out an error, try to go the other way. Try 45 and then sine. Or reverse. If you type in 45 and sine and it gives you an error, then try typing it the other way. The other thing that could be the issue is your calculator needs to be in something called degree mode. Most likely your calculator is already in degree mode, but if it's not, there's another mode that's called radians. So you can see on my calculator right here, this third one down, a radian, which we'll talk about in Algebra 2, is another way to measure an angle. And we want to make sure our calculator's in degrees. So if you feel like you're typing it in the right way, but you're not getting this decimal, send me an email so we can figure out your calculator together. And then I would strongly recommend writing right here so you don't forget, how do you put it in your calculator, okay? How do you put it in your calculator? All right, so hopefully you've got your calculator figured out. Now we're actually going to do something with this stuff. So we're going to find missing side lengths. We're always going to round to the nearest tenth. That means 1 decimal place. So it's important for us to know how to round. Okay, so this is our example number 1. We've got a right triangle. I know it's a right triangle because I've got my mark there. We know one angle is 55 degrees. This side is 10 and this side is x. So first thing that you should do is, like, before you work too hard, is like using the trig stuff. Can you use the Pythagorean theorem? Can we just, I mean, we're finding a side. Do we have enough information to do the Pythagorean theorem? So that's a squared plus b squared equals c squared. In this case, we don't, because for a Pythagorean theorem, we'd have to know 2 sides to find the third side, or this would have to be isosceles, so we could do that, and we don't know it's isosceles. Actually, I do know it's not isosceles, because if it were isosceles, wouldn't these 2 angles have to be congruent? Which means both of those would be 45. So this is not isosceles. So we can't use the Pythagorean theorem. So then we need to know which sides are helpful. Well, we know which sides are helpful because the ones that have numbers on them, or what we're looking for. So the 10 is helpful and the x is helpful. And now we need to figure out which trig function we need to use. So to figure that out, we need to put Bob at our reference angle. So Bob is at our 55. We're going to label our sides, opposite, adjacent, hypotenuse. I'm going to write SOHCAHTOA here so I don't have to keep remembering it. So 10 is the opposite side. X is the hypotenuse. Awesome. So which trig function, sine, cosine, or tangent, uses opposite and hypotenuse? All right, so that's sine of 55 equals 10 over x. Opposite on top, hypotenuse on the bottom. All right, so this is what we did yesterday, and yesterday we would have stopped here. So today we're going to forge ahead. So we are going to actually figure out what x equals. So to do that, there's a couple different strategies. So the first strategy is we need to get x out of the denominator. Okay, step one, get x out of the denominator. So here's one way we can do that. Since this is divided by x, we can break division of x by multiplying by its inverse. So x, we're going to multiply by x. So we're going to multiply both sides by x. So when we do that, these x's will cancel out. So we're left with x sine 55 equals 10. Now I'm writing the x in front on purpose because if I write it behind it, if I write sine 55x, doesn't it look like the 55 is being multiplied by x? But it's actually the whole thing that's being multiplied by x. So if you want to write in the back, that's totally fine, but just make sure you put parentheses around it, okay? I write mine in the front so I don't have to do that. Now, the sine of 55 is a number, right? We just got done practicing that, so sine of 55, it's just a long, crazy decimal. So we are just going to divide by it. So for instance, if this were just x times 55, we would divide by 55, right? This is just representing a number, so we're going to divide by that number. And I'm not going to write the decimal. I'm going to be as accurate as possible, which means I'm going to try to save all of my rounding to the end. But whatever I do to one side, I do need to do to the other. So my signs will cancel out, and x is equal to 10 divided by the sine of 55. So this is its exact answer. If you ever heard your math teacher say exact answer and approximate answer, the exact answer is pretty much like what do you get right before you type in your calculator. So this is our exact answer. So now I'm going to approximate it. So I'm going to use that because I'm going to have to round this. So 10 divided by sine 55. So you should get 12.2 because we're going to the nearest tenth. So that 0 tells me to keep it at a 2. So 12.2, and that's a length, so I'm going to say units. Now, if you didn't get 12.2, it's possible you have the backward calculator. So I have the one where I just literally type it the way I see it. So if you need to type it in backwards, here's where it gets a little tricky. Backward. You're going to have to type in 10 divided by 55 sine, and then don't forget to hit equals, okay? That equals is really important. Otherwise, your calculator will just show you the sine of 55. So if you have the backward calculator, it's going to be 10 divided by 55 sine equals. If you have the forward calculator, it's 10 divided by sine 55 equals. All right, so hopefully you got that 12.2. All right, let's try another one. All right, so first question, can we use the Pythagorean theorem? A squared plus b squared equals c squared. We only have one side for Pythagorean theorem. We'd have to know two sides, so we cannot use the Pythagorean theorem. So which sides are helpful? Well, the two sides that are labeled are going to be the helpful ones, so this x and that 4. And this angle is going to be helpful. So I'm going to put Bob right here. Now we could totally use this angle right here if we wanted to set Bob at this corner, but we would have to do some math to figure out how big this angle is because we have to know at least one of those angles. All right, so if I set Bob up here, then the 4 is the opposite side and the x is the adjacent side. All right, so which trig function uses opposite and adjacent? So that's tangent. So we're going to do tangent. Where's Bob standing? 25 equals opposite has to go on top, adjacent has to go on bottom. All right, so we have a different trig function, but actually if you look at it, it's set up very similarly to this first one. So we're going to solve it potentially the exact same way. So instead of dividing by x, we're going to get rid of dividing by x by multiplying by x. Multiplying by x. So that gives us x times the tangent of 25 equals 4. Now the tangent of 25 is just a number. Tangent of 25. Your calculator has that number saved. So if we have x times tangent of 25, then to get rid of times, we're going to divide. And now this is what will get typed into your calculator. So if you have those forward calculators, you're going to type what you just wrote. So 4 divided by tangent 25, hit equals. So you should get approximately 8 point. So this is 8.57. The 7 tells us to round the 5 up to a 6 units. Now if you have the backward calculator, when you type this in, you're going to type in 4 divided by 25 tangent, and then don't forget to hit equals. That part's really important. Otherwise, it'll just tell you the tangent of 25. So type it in, see if you can get it right. All right, we just have a couple more problems to do. These ones are really just for practice here. So these problems are a little bit different though. If you notice, we actually have 2 things to find, where on those first 2 problems, we only had 1 thing to find. So we're gonna have to write 2 different trig functions and solve 2 different trig functions for each problem. So can we use the Pythagorean theorem? Nope, we only have 1 side. Which sides are helpful? Well, that kind of depends on which side we're gonna find first, right? So let's put Bob in our picture and label our sides. So I put Bob at the 66, that would make this side opposite, the 100, the hypotenuse, and then the y is adjacent. So just like yesterday, we're going to decide what do we want to find first, x or y. It doesn't matter. So we'll go in alphabetical order like we did yesterday. So I'm literally going to cover up y. I'm going to write my SOHCAHTOA again. And I'm going to look at what I have. So I have opposite and hypotenuse. So that is sine. So we've got the sine of Bob standing at 66 equals x over 100. All right, this problem is a little bit different from this one because you see in this first problem that we did, x was in the denominator, but this time x is in the numerator. So when we did this first problem, we got x out of the denominator by multiplying by x. We're going to use a similar process, except we don't have to get x out of the denominator. We need to get rid of the 100. So instead of dividing by 100, we're going to multiply by 100. Okay, so that gives us 100 times the sine of 66 equals x, because those 100s will cancel. So again, notice that I put the 100 in front, because if I write it like this, sine of 66 times 100, it's going to look like I'm multiplying the 66 and the 100. If you want to write the 100 behind it, which is totally fine, you need to put parentheses around that so you don't forget that you're multiplying the whole thing by 100, not just the 66, okay? All right, so 100 times the sine of 66, our goal is to figure out what x equals. Isn't x by itself? So we're practically done. All we have to do is solve it now, or type it in our calculator. So this is the exact answer. So our approximate answer is what we get after we type it in our calculator. So I've got 100 times the sine of 66. So we should get 91.35. Oh, 1 decimal place. So 91 point, the 5 tells us to go up to a 4. All right, now let's see if that makes sense. The hypotenuse is 100. Is it possible for this side to be 91.4? Absolutely. We want to make sure our hypotenuse is the longest side. So that's good news that that's smaller than 100. All right, let's set up a second one for y. So I've already got everything labeled. I don't need to move Bob, so I'm going to leave Bob there. I'm going to cover up the opposite side this time, which means I have adjacent and hypotenuse. So we're going to have the cosine, adjacent and hypotenuse, cosine of 66, where Bob is standing, and then adjacent has to go on top, hypotenuse has to go on bottom. Now this problem is actually very similar to this one now. So we're going to multiply by 100. So 100 times the cosine of 66 equals y. Y is already by itself, which means all we have to do is type in 100 times the cosine of 66. So 40.67, so that 7 tells the 6 to go up to a 7. All right, so does this make sense? Does it make sense that x is bigger than y? Do you remember when we talked about 30, 60, 90 triangles and we talked about how the smallest angle is across from the smallest side and the biggest angle is across from the biggest side? Let's see if that works here. So we got y to be 40.7. We got x to be, what, 91.4. We know that this angle is 66. So, that should have had a right angle in it. So we knew for sure it was a right triangle. So if I wanted to know this angle, 180 minus 90 minus 66, that's 24. Is our smallest side across from our smallest angle? Our biggest side across from our biggest angle? And our medium side across from our medium angle? Absolutely. So all of these numbers make sense here. All right, I'm going to have you try this next one on your own. So I'd like for you to pause the video, draw in Bob, label your sides, set up your trig functions, and then start the video again when you have an answer to see if you got it right. All right, so Bob goes here. We've got opposite, hypotenuse, adjacent. I'm going to start with x, so I'm going to cover up y. It's opposite and hypotenuse, so sine. Sine of 25 equals opposite over hypotenuse. X is in the denominator, so we're going to multiply by x. X times the sine of 25 equals 10. This is just a number, so we're going to divide by it. Sine of 25. And x is equal to 23.7. How'd you do? Did you get it? I'm going to change my equal sign to approximate just because it's not the exact number. It's a rounded decimal. All right. If you haven't found y yet, go ahead and pause the video again and see if you can figure it out. So this time for y, I'm going to cover up hypotenuse, opposite and adjacent. That's tangent. So tangent of 25 equals opposite has to go on top. So we're going to multiply both sides by y. Sorry, I'm out of room here. So y times the tangent of 25 equals 10. Divide both sides by the tangent of 25. So y equals 10 divided by tangent 25. Y equals 21.4. How'd you do? Did you get it? Let's see if these numbers make sense. So we got 23.7 for our hypotenuse. And we got 21.4 for y. Is this the biggest side? Sure is. Bigger than 10, bigger than 21.4. It's across from our biggest angle. It should be the longest side anyway because it's the hypotenuse. If this angle here is 25, 180 minus 90 minus 25, this angle would be 65, which means the smallest angle is across from the smallest side and the medium angle is across from the medium side. So all of these make sense. All right, last problem. This one is just a challenge one. So we're going to do this one together. We're just going to use some of our quadrilateral skills to help us. So it asks us to find the perimeter of the rhombus. So we know it's a rhombus. All these sides are the same. If AW, so that's this entire thing, is 20, and KWE, if this whole angle is 58. All right, so we need to remember a couple things about a rhombus. We already marked that these four sides are congruent, which means all I need to do is find one side so I can multiply by 4 to find the perimeter. Do you remember the diagonals of a rhombus are perpendicular? Now that's really good news because that creates a right triangle, which means then we can do either Pythagorean theorem or we can do trig to help us. AW is 20, so the whole thing is 20. Well, since this is a rhombus, the diagonals bisect each other because it's also a parallelogram, which means each side of this is going to be 10. The last information that we know is KWE, this entire angle is 58. Well, the diagonals also bisect the angle, so if this whole angle is 58, then I'm going to do 58 divided by 2 to find that this little guy here is 29. So then, if I take this right triangle that's right here, I know this is 10 and this is 29, so that's this triangle right there. I can use that to find, I'll call this x, kw, and then since that's one side, I can just multiply by 4. So go ahead, do it. Pause the video, see if you can figure it out. All right, so I drew my picture and labeled it a little bit, so if you needed a little bit of help. Next, I'm going to solve it, and so in just a second, when I come back on, it'll all be solved. All right, so SOHCAHTOA, I decided to use cosine. So cosine of 29 equals 10 over x. Multiply both sides by x, divide by cosine of 29. I got 11.4. Now, what is 11.4 representing, though? That's just one side. We want the whole perimeter. So what's the last thing we need to do? 4 times 11.4. So our perimeter is equal to 45.6. Our units were centimeters, so centimeters. How'd you do? Were you challenged? Did it make sense? If you have questions, please reach out. I'm happy to help you. Otherwise, have a fantastic day.